We now move on to solving logarithmic equations by base conversion. Okay, we've seen solving logarithmic equations by direct conversion. We've seen it uh, by using the laws of logarithm and all of that. So now we'll be looking at how to solve logarithmic equations by base conversion. So the deal here is the bases are not the same, but then we want to get them to be the same before then we can then apply other rules. So imagine you want to solve something like log x to base 2 equals log x plus 4 to base 4. So the bases are clearly different. Okay. So um so when logarithm equations have different bases, you need to convert to a common base and then you use logarithm laws, then solve algebraically and check domain restrictions. So to be clear, by way of reminder, right, let's remind ourselves of the laws of logarithm, right? So laws of logarithm, okay, laws of logarithm. First of all, we have the power law, which says that the product law, actually, if you have log A. So, I mean, log if you don't indicate the base, just take it as 10. So log A plus log B is equal to log AB, all right? That's log AB to the same base 10. That's one. Number two, log A, the quotient law now, log A minus log B is equal to log A over B. That's simply log A over B to the same base. Then number three, we have the power law, which says that if you have log A raised to power n, that's the same thing as n log A. Okay. I mean, these are three popular ones we know. But then we have other ones like this. Number four, that log A to base A. I mean, let's say let's say log one, log one is simply zero because 10 raised to power zero is one. That's a very direct one. Number five, we also know that log A to base A is equal to 0. That's like saying log 10. So log A to base A is 1, sorry. That's also like saying log 10 is equal to 1 because log 10 to base 10 is 1. Or that's also true for ln E. Okay. That's also true for ln E, which is 1 because ln E is log E to base E. Okay. That's another law. Another law if you want to think about is this. Like if you have say log a to base 1 over 10 because the base is a fraction now. The base can be it must be greater than 0. It must not be 1, but it can be a fraction like 1 over 10. So if you have log a to base 1 over 10, just add this, you just have minus log a base 10. That's what that simply means. Okay, that's what that is about. Then number 7, we also have that log a to base, say, 10 raised to power n. Okay. So if you have log a to base 10 raised to power n, so the base is the one with the power now. That will simply be this power, you just come 1 over n log a to base 10. All right. So that will be log a to base 10. Of course, this is simply the same thing as minus log a, right? Because if you don't write the log, it's okay. So this is log a to base 10, or you say 1 over n log a like that. Okay. So these are some laws we need to always have in our minds when we solve some of these problems. Okay, so with that in place now, we go on to solve this log x to base 2 equals log to base 4 of x plus 4. You can already see that this is log x to base 2. So log 4, based on that rule, should just be log 2 squared, and that'll be half log x plus 4 base 2, something like that. Okay, so our strategy, like we said, is to convert to a common base, use logarithm laws, and solve algebraically, and then you check domain restrictions. So in step 7.2 now, 17.2, in step 17.2, we have step 2. So here you convert to a common base. First of all, we know that x 4 is equal to 2 squared, right? You can see this is base 2, this is base 4, but we know 4 is equal to 2 squared. And if that is the case, we know that log x plus 4 to base 4 is the same thing as log to base 2 of x plus 4 all over log 4 to base 2. So you can have them in the same base like that. So, and this is talking about the idea that I think that's another thing we've come across previously, that if you have say log a to base b, it's the same thing as saying log a over log b. So if you like whether to base 10, you know, or it's still the same if you have log a to base 2 over log b. As far as you take it to the same base, you are good to go. And that's what is happening there. So there are many approaches. So if you don't remember the laws directly, you can also use this idea. So you have log x plus 4 to base 4. That's the same thing as log x plus 4 because the other base is 2. So you can now say log x plus 4 base 2 all over log 4 base 2 like this now. So log of x plus 4 base 2 and log of 4 itself base 2. And if that is the case, we know that log 4 base 2 is the same thing as 2 because log 4 is 2 squared. So uh log 2 squared base 2 is simply 2 log 2 base 2, which is simply log 2 base 2 is 1. So this is simply 2. So now we know that log x plus 4 base 4 is the same thing as half. So it's the same thing if you just come and say that you have log. So it's the same thing, right? When you do what I said the other time, and you just know that log to base 4 of x plus 4 is the same thing as log 2 squared. The base is now 2 squared, x plus 4. Log x plus 4, 2 squared. And because of this power 2 now, that's n. So you just have 1 over 2 log x plus 4 to base 2. So it's the same. Anyhow you go about it, you get the same results. So now this log x plus 4 to base 4 now is the same thing as half log 2 x plus 4. And of course, you can also take this half now on top of x plus 4, you know. So, but I mean, we have rewritten this one. Now it is in base 2. That's the most important thing to start with. You want to get the two into the same base because we're talking about base conversion. So let's talk about substitution. Now, how do you substitute? The original expression says log x to base 2 is equals to log x plus 4 to base 4. Now we have log x to base 2 equals log x plus 4 to base 4 is the same thing as half log x plus 4 to base 2. So the bases are the same now, but you want to isolate the logs, right? What do? So you can multiply both sides by 2 if you like. So you can put the half here, you can push the 2 here. So you multiply both sides by 2 so that you can take away this half. So you have 2 log x to base 2 equals log x plus 4 to base 2. And then what do you do next? You can apply the laws, the log laws. So one law that applies here is that, this power is here. This 2 is there, so it can become the power of x so that you can isolate. So the bases can really be comparable. Okay. So using the power rule, we know that n log a to base b is the same thing as log a raised power n to base b. So 2 log x to base 2 is log x squared to base 2. Thus, the equation becomes log x squared to base 2 equals log x plus 4 to base 2. And with this now, we can then equate arguments. So we can then have x squared equals x plus 4. Now, the bases are the same, and then we can just compare. So since bases are equal, we have x squared equals x plus 4. Then you solve. So to solve now, you solve the quadratic, which is now x squared minus x minus 4 equals 0. And if you use the quadratic formula, you get x equals plus that minus b. Minus b here is b here is minus 1. So minus b means minus 1, which is 1, plus or minus square root of b squared, which is minus 1 squared, and that's 1, minus 4 AC, that's 4 times 1 times minus 4, that's plus 16. So you have 1 plus or minus square root of 1 plus 16 over 2. That's x equals 1 plus or minus square root of 17 all over 2. And that is it. Okay, but did we have to do a domain restriction? I think domain restriction is still important. We'll have to do domain restriction on top of this on the original thing. X should be greater than 0 and x should be greater than minus 4, but x greater than 0 is stronger. So, but I mean, we have that, right? So let's go and apply domain restrictions. Okay, I think I was ahead of myself. So here, logarithm conditions now. First of all, from the expressions now, we have the original thing. X has to be greater than 0 and x plus 4 has to be greater than 0. Okay, so here we have, where is it now? Yeah, here we have x should be greater than 0 and x plus 4 should be greater than minus 4. X plus 4 should be greater than 0, meaning x should be greater than minus 4. So if x is greater than 0, it's automatically greater than minus 4. So the strong condition is x equals 0. The stronger of the two is x greater than 0. So x has got to be positive. So negativity should be rejected. Now we know square root of 17 is 4 point something. So 1 plus 4 point something is 5 point something over 2. Whereas 1 minus 4 point something will be negative. So we have to reject this negative result and accept the valid one. So the final answer we have there is that x is equal to 1 plus root 17 over 2. That's what works in that particular situation. So let's look at example 2 now. So for example, 2, we need to solve log x to base 3. Okay, log x to base 3 equals log x plus a to base 9. Same story. Log 9, log x to base 3. So this is base 3, this is base 9. They are not the same. So you have to convert 9 to base 3. So what do? You know, 9 is 3 raised to power 2. That simply means you have half log x plus 8 to base 3. So in that case, you can equate the base. So just like before. So the same kind of approach. So you have this that step one, you express base 9 in terms of 3. 9 is 3 raised to power 2, clearly. So you can convert, you say log x plus 8 to base 9 is the same thing as log x plus 8 to base 3 all over log 9 to base 3. So it's the same thing as when you have log b base 8. It's the same thing as log b all over log a to the same base, any base you choose. But because we want 3 here, we can choose 3. And since we know that log 9 to base 3, 9 is 3 raised to power 2. So we know log 9 to base 3 is 2. So as a result of that, we then have log x plus 8 to base 9 to be the same thing as half log x plus 8 to base 3. And then again, we do like before. So overall, we have log x to base 3 equals half log x plus 8 to base 3. Then we can multiply through by 2. So we have 2 log x to base 3 equals log x plus 8 to base 3. Then we apply power rule now. So that means you have to isolate the log. So 2 can carry, x can carry 2 on it. So we have log to base 3 of x squared equals log x plus 8 to base 3. And then we can equate now. So you have x squared equals x plus 8. So you then have x squared minus x minus 8 equals 0. So x is equal to 1 plus or minus root 33 over 2. So uh so what's the domain restriction? The domain restriction has to be that, first of all, x has to be greater than 0, and then x plus 8 has to be greater than 0. So x plus 8 greater than 0 means x is greater than minus 8. So x greater than 0 is stronger than x minus greater than minus 8. So you take x greater than 0. So you then solve, and then the final answer is the positive one, because 1 minus root 33 will be negative. So you pick the final answer to be the positive answer, which is 1 plus root 33 over 2, like this. Okay. Now, we can also have mixed base logarithmic identities. So there are some identities that can help us in this case. So some of them I talked about previously. So we can have the reciprocal identity, which tells us that log b base a is the same thing as 1 over log a base b, right? So that simply tells us that, okay, if you have log b to base a, that's the same thing as 1 over log a to base b. That's another very important identity right there. Okay, so we have that. We also have other ones like you can change base now. Log m to base b is the same thing as log m over log b to the same base, any whatever your k is. That we apply that already. Then we have the power rule that log x raised power n to base b is n log x to base b. So we use that a lot in this conversion thing. And of course, I also explained to you, like the other time when we had log x plus 8 to base 9. And since the other one is to base 3, this is the same thing as log x plus 8 base 3 raised to power 2. And because of this 3 raised to power 2 here, all you just need to do is 3 raised to power 2 comes as half. So you have log. I proved it in one of the videos. So to base 3 now. So we can easily do this. And then we keep going with what we are doing. Okay. So again, you cannot evaluate this as log x to base 2 dot log 2 to base x. Of course, x to base 2, 2 to base x, they are reciprocal of themselves. So using the reciprocal identity that log x to base 2 is equal to 1 over log 2 to base x, we can say that log x to base 2 times log 2 to base x is equal to 1, like that. Okay. So let's go for practice problems where I get to solve 2 of the problems, one from 1 to 10 and one from 11 to 20. Here, which question looks the craziest? Okay, I think I'll go for question 8, right? Yeah, question 8. I like question 8. Let me go for it. Question 8 now. So question 8, then I copy that. Question 8, then I take it to the worksheet, and then I'll deal with that. So I right click and paste question 8. That's what we're solving. So log x base 16 equals uh, log x base 16 equals log x plus 12 to base 2. Okay, so one thing you should clearly do is find they are not the same base 12 base 16 base 2, but you should be able to write this base 16 as 2 raised power something. So and following the law I told you, so we have this is log x base 16 equals log x plus 12 base 2. So what can you do with this? So 16 is 2 raised power something, right? So x 16 is 2 raised power 4, right? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So 16 is 2 raised power 4, and that's equal to log x plus 12 base 2. Okay. And what did I say about this power? Recall, I once told you, recall that when you have log a base 10 raised power n, it's the same thing as whatever the base may be, though, it's the same thing as 1 over n log a base 10. Okay, so that's very useful, whatever the base may be. So now we can take this to say that since we have log x to base 2 raised power 4, that means we have 1 over 4 log x to base 2, and that is equal to the right hand side. That's log x plus 12 to base 2. So they have the same base now. So what can we do then? We can multiply through by, so we can multiply through by 4. So multiplying through by 4, we have log x to base 2 equals 4 log x plus 12 to base 2. Okay, so now but then before we can compare what you have in front of the logs, you have to isolate the log. So we have log x to base 2 equals log x plus 12 raised to power 4 to base 2. Okay, so that means we can then say, okay, we can then say x is equal to x plus 12 raised to power 4. Now, this is a big issue when it comes to solving. This is a challenge to take care of. What do we do here? We are going to get 4 answers. This is a lot actually to deal with. So what I'm just going to do is I can expand all this, right? But I'm just going to use Desmos for this and just write out the answers. Okay. This power 4 is a big one. Okay. So normally I should expand it and start solving, but I'll just say x equals x plus 4, x plus 12 raised to power 4 on Desmos. Let's do that. Okay. So we know that x is equal to x plus 4, x plus 12 rather, raised to power raised to power 4. Do we get anything from that? That's not giving us anything. Oh, yeah, it's giving us some. Yeah, okay, I get it. Okay, so this is equal to x actually. Should give us something. Really? Okay, why? I think everything is fine from the beginning, yeah. Everything is good. Yeah, everything is good. So we should get something. Or maybe all the solutions are imaginary. Okay. All the solutions might be imaginary. So let me go to Wolfram Alpha and see what it has to say. I guess the solutions might be imaginary solution. Wolfram Alpha. So we want to solve x equals x plus 12 raised to power 4. So if I want to solve it manually, to be a lot of stress. That's why I'm doing this. Aha, okay, I get it now. All the answers, all the solutions are imaginary. Okay. So, but then these are the solutions right here. Okay. Aha, but maybe instead of before even maybe the domain, taking the domain would have been fine. Maybe taking the domain issues, but the domain looks good. First of all, this one says x should be greater than 0, and here x should be greater than minus 12. So generally speaking, x should be greater than 0. So, yeah, the domains, we have complex solutions, okay? Complex solutions. So all solutions are complex based on what Wolfram Alpha has given us. You can see all the solutions have imaginary terms. So, yeah, that's what this is about right here. Okay, so we are good with that. And then, okay, let me take the second question from 11 to 20. Okay, so what should I pick now? Of course, all these ones, they are cool. Let me see which ones. Okay, I guess I'm gonna take, let me take question 16. Yeah, all the questions are somewhat challenging, but let me go for 16 here. 16. So take snip 16, then I copy that and take it to this place. So I right click and paste. Yeah, so we want to solve for x. So straight off, let's talk about the domain. I think the domain should come first. X greater than 0, yes, that's from here. Then x minus 1 should be greater than 0. That means x is greater than 1, all right? Then here, x should be greater than minus 8. So the strongest is x is greater than 1, because if x is greater than 1, it is automatically greater than 0. It is automatically greater than minus 8. So let's go then and solve the problem. Right, so um, we have log x to base 3 plus log x minus 1 to base 3 equals log 9, log x plus 8 to base 9. So the bases are not the same. So, but we can express 3 as a 9 as a as as if in terms of 3, right? So we have log x to base 3 plus log x minus 1 to base 3 equals log 3 squared. That's the base now. Log x plus 8 to base 3 squared. And then, of course, as usual, you still want to recall, recall that the log of, say, b to base a raised power n is the same thing as 1 over n log b base a. So this power comes as a fraction multiplying the whole thing. So as a result of that, we can go back and then have log x to base 3 plus log x minus 1 to base 3, and that is equal to 1 over 2 log x plus 8 to base 3. So we can multiply through by 2. So we have 2 log x to base 3 plus 2 log x minus 1 to base 3 equals log x plus 8 log x plus 8 to base 3 now. So then we need to isolate the logs. So we have log to base 3 of x squared plus log to base 3 of x minus 1 squared equals log to base 3 of x plus 8. And then we can apply the laws of logarithm, and we have log to base 3 of x squared all over x minus 1 squared equals log to base 3 of x plus 8. And then we can have, we can expand, we can just equate now. So we then have x squared over x minus 1 squared equals x plus 8. So, okay, I think we can still handle this. So we have, we can handle this, I believe. So we have x squared equals x plus 8 into x minus 1 squared. So that means x squared is equal to x plus 8. X minus 1 squared is x squared minus 2x plus 1. And then we have x squared equals x times x squared. That's x cubed. All right, x times x cubed minus 2x squared plus x plus 8x squared minus 16x plus 8. What I've done is x times x cubed, x times minus 2x squared, x times 1x, 8 times x squared, 8x squared, 8 times minus 2x minus 16x, 8 times 1 is 8. Okay, so now we can tidy things up a little bit. So we have x squared equals x cubed Then here, minus 2x squared plus this, that's plus 6x squared. X minus 16, that's minus 15x plus 8. So we can put all the terms together. So we have 0 equals x cubed plus 6x squared minus, that's 6x squared minus x squared minus 15x plus 8. So in all, we have x cubed plus 5x squared minus 15x plus 8, right? Equals 0. I guess x cubed plus 5x squared minus 15x plus 8 equals 0. Yeah, from the laws, from polynomial equations that we solved the other time, we can then begin to look for the roots of this now. So we need to try, we can try different factors and see which one goes. So, and those factors should be factors of 8, you know. So possible solutions should be, so from the polynomial situations we did, so possible solutions, right? Possible solutions are factors of 8, okay? So that's factors, that's rational root theorem. So that's possible solution, that's factors of 8 divided by factors of 1. This one in front of this place, right? But since it's 1, so we just say factors of 8 alone. So here now we just have factors of 8, that's plus or minus 1, plus or minus 2, plus or minus 4, and of course, plus or minus 8. But so we start with the small ones. So we try one, try. So now it's more like we have, okay, we can even try. So if we try, so now we have f of x to be equal to x cubed plus 5x squared minus 15x plus 8 equals 0. So we try 1, right? So try 1. So f of 1 equals 1 raised to power 3 plus 5 into 1 squared minus 15 into 1 plus 8. Okay, we don't need 0 here. So this is 1 cube. This is 5. 1 plus 5 is 6. 6 plus 8 is 14, right? So 6 plus 8 is 14. 14 minus 15, that's minus 1. So uh, this is not equal to 0. So that simply means that x minus 1 is not a factor. X minus 1 is not a factor. So we go for another one. So this is what we are testing now. So I could just go to Desmos and do it, but since this one is still, we can still handle this. That's why I'm doing all this. So let's try f of minus 1 now. For f of minus 1, we have minus 1 cube plus 5 minus 1 squared minus 15 into minus 1 plus 8. So this is minus 1 plus 5 plus 15 plus 8. Okay, the case is even worse here. That's 28 minus 1, that's 27. This is not equal to 0, okay? So x plus 1 is not a factor. X plus 1 is not a factor since f of minus 1 is not giving us 0. So let's go for 2 now, okay? So we do 2. So f of 2 now. What does f of 2 tell us? F of 2, we have 2 cubed, 2 raised to power 3, then 5 into 2 squared, 5 into 2 squared, then we have 50, minus 15 into 2, minus 15 into 2, plus 8, I believe, plus 8, okay? So we have 8 minus 2 raised to power 2 is 4. 4 times 5 is 20, minus 30, plus 8. Okay, we are in for more issues, right? Okay, this is plus, right? So this is 28 minus 30, yeah? Yeah, 28 minus 30, that's minus 2 plus 8. That's minus 2 plus 8, that's 6. Still not equal to 0. Still not equal to 0. So what do we say? So x minus 2 is not a factor. X minus 2 is not a factor. So, well, after f of minus 2, if f of minus 2 does not work, I'll just retire. So then I'll just go to Desmos and get the solutions. It's possible that all the solutions are complex, but I'll just try this one more. So I have minus 2 raised to power 3. All right, from the expression minus 2 raised to power 3, 5x, 5 into minus 2 squared, then minus 15 minus 2, minus 15 minus 2, then plus 8. I suspect this is not going to work too, but it's okay. So we have minus 8 plus 20 plus 30 plus 8. So that gives 50, which is not equal to 0. Wow, which is not equal to 0. So again, x plus 2 is not a factor. Okay, I think this is getting too long. So what I'm just going to do is I'm just going to use Wolfram Alpha to solve it, and we'll forget about the story. So again, what this is what we have: x squared, over. So we have x squared all over x minus 1 squared equals x plus 8 equals x plus 8. So I just put that in Wolfram Alpha and solve, because I suspect all the answers might be imaginary. Okay, so this is x squared, solve x squared all over x minus 1 squared equals x plus 8. X plus 8, right? X squared over x minus 1 squared equals x plus 8. So Wolfram Alpha does a quick job. Yeah, you can see how complicated the solution is, and they are all imaginary, okay? So we get some complex solutions. That's why the roots were hard to come by. So we have some imaginary solutions. Imaginary solutions, or if you like, complex solutions. Okay. So it's as good as the solution don't exist in the real domain. Yeah, so with this, we come to the end of this interesting video about solving logarithms by making sure the bases are the same, right? Yeah, by base conversion, right? By base conversion, and you won't forget those laws that make base conversion very easy to handle. Let me know how helpful this is for you, and if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, guess you need to do that right now. Subscribe and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you also want to become a member of this channel by clicking on join. That gives you some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here till I come your way again. Keep doing maths right. Bye.